All right, looks like it's just clicked over to 10 o'clock. Good morning, everyone. Thanks for joining us again on our long coffee break mini series. My name is Leroy Willow. I'm a sales engineer out of Grand Junction office in Colorado. Joining me today is Ken Rubbage. He's the Vice President of Business Development with KE Fiber Tech. And today we're going to be talking Fabric Duct 101. So with that, Ken, I'll turn it over to you.
All right, fantastic. We are fighting with PowerPoint. It is not wanting to behave. It shows the 12 slides, but it is not wanting to switch and go forward. Let's see if we can do it this way. There we go. All right.
So we're still on the same screen. Oh, there we
Yeah.
go. There we go.
Yeah. We have movement now. That's the big thing. All right, guys. So I guess one of the first things that we'll discuss about is why Fabric Duct. There's some key points on there, and Fabric Duct has a huge place in the air distribution industry if you look at it as a whole. Part of the reasons that it's used across the board in a lot of different projects is its versatility. It's lightweight. It's easy installation. It's easy to transport. You get some unique materials and colors. And it's also, most manufacturers are UL 2518 certified. We'll talk about that towards we get to the end of the presentation. I'm not going to bore you with the codes on the beginning of it. But when you look at the lightweight and the easy to transport right now, that's a little more important than it used to be. Fabric duct is typically sent in two different sections. The hardware is sent one way, and then the ducts themselves, the major part of the project, they come in usually 2 by 2 by 2 boxes. And you can fit a 48-inch round duct in a 2 by 2 by 2 box and ship it UPS across the country. And the cost of that is just phenomenally different than having something freighted in like steel. The other thing is when you start to install this, you're not dealing with all that weight. You're not looking at sealants. You're not looking at having to paint it. It comes pre-colored, as I said, unique materials and colors. So those things make it a pretty versatile product as we move across the board. But what most people seem to do, and what we see a lot of, and probably 70% of the duct work that we see in the United States is in schools and pools. And of course, that's the old standard, but there's a lot more places that you can utilize Fabric Duct. There's a lot of places that can solve problems for you. One of the things that you can do with Fabric Duct that a lot of people don't realize is it doesn't condensate if you pick a porous fabric to go with the duct. And you can get those porosities across the board, and we'll discuss those a little bit later. But when we're talking about Fabric Duct, the fabric is the main thing. That's what matters. That's the main component of it. And KE Fibertech has taken a little bit different approach than some of the other manufacturers. We've invested in our own weaving mill. We are the only ones in the world that own our own weaving mill that actually is right across the parking lot from the factory. Having this weaving mill gives us control over our materials and our processes. And again, right now, that's really important. With what we're seeing out there with the delays and the material scarceness, we're not experiencing that because we control our base material. It's made right across the parking lot. It also gives us a huge amount of control over the quality of the material and pricing. We haven't experienced the extreme swings in pricing that a lot of our competitors have, or in other parts of this industry that we've seen. Because we control the main component of our product, it gives us that steadiness, that reliability that we enjoy. Now, the fabrics that we produce, KE Fibertech uses 3 basic fabrics, and we build upon those fabrics. Because we own our weaving mill, we can take 3 basic fabrics. We can add antimicrobial to it if needed. We can add anti-static, and it comes in multiple porosities, 2 CFM all the way up to 74 CFM. And if you choose the green weave or the multi-weave, you can get that all the way down to 1 CFM. Now, we do have the 0 porosity material, and we offer that for transport mostly for a non-steel type duct, but we don't use it a whole lot here in the United States because it does eliminate one of the key benefits of Fabric Duct, which is the elimination of condensation. But one of the key things you'll notice here, if you look down at these two different fabrics, the green weave and the multi-weave, you'll notice the blue profile is slightly different. We achieve that by changing the way we weave the material. Both of these things are exactly the same as far as its base material, the base fiber. The multi-weave and the green weave start out exactly the same. But it's the way the fibers are woven, the way they're put together, and the way it is the control of the weft on here. One's higher, one's lower. The difference in that height gives you a dust holding capability that is much different. So if you would actually touch this fabric, the green weave is going to feel more like a soft sweatshirt. It's going to have a much softer feel, and it can hold a lot more dust. So if you're in a critical environment, like a bakery, the green weave is used in bakeries all across the country where they have the flour that gets up through there. It's used in paint booths. Whereas the multi-weave is going to feel more like a tight jacket, a rain jacket that you would touch and feel. It's still a textile, it's polyester, but it's much tighter woven and it doesn't hold as much dust in it. Now that's good for a couple of reasons. It's much more robust and it will not really let much dirt penetrate it. But it does require more maintenance if you put it in the wrong application. So the key with Fabric Duct is picking the right application and picking the right fabric for that. And so when we look at this a little more in depth, we start looking at the versatility in the air distribution. So if you look all the way to the far left, you see a laminar flow where it's just purely putting volume of air into the room. And that's something you would see in those higher porosity fabrics. We use this, of course, in laboratories, computer chips, production facilities, things where velocity causes a problem. And then we have the inject system that's next to it that is got small holes and jets on there, as well as a porous fabric. That gives us the ability to utilize a softer velocity, but also during a heating mode, push the air down into the space. So the one on the left, you would definitely not use anywhere where you need heating. It's strictly a cooling application because it drops down, or an air volume. Then we move over to the middle section, the dire jet. That's the nozzles. We'll look at those a little tighter, but those really can throw some air. You can push air down 50, 60 feet into the occupied zone with a nozzle in the correct sizing. And then we look at the two non-porous systems that we do offer. And you can see the difference that there's really no air coming out of the duct itself. 100% of the air has to come out of the orifices. And that's mostly, again, for transport where there's a little bit of distribution needed, or in a certain type of environment. We would use this, let's say in a agricultural or some kind of environment that was extremely harsh, poultry production, maybe, those type of things. But the big thing we want to look at, and this is the core of the products. I know this is a little blurry, it's kind of large, but if you look here, this is the proper way to design a fabric duct. And if you'll notice, the actual smoke that's coming out of the duct and the surface of it is being pulled back into the jets, into the holes. And that's the proper way to do it. Those other videos that you saw was a little exaggerated so that you could see the smoke. But if we were to design a fabric duct system, this is how we would do it. We couple the velocities with the porosity of the fabric with a hole size. And if we do those things correctly, which we should every time, because we have some very sophisticated software that's devoted strictly to fabric ducts and to air distribution that we design with, we can achieve this on any project. So what it does is it creates almost a mini atmosphere around the duct. That helps with dust, and that, of course, eliminates condensation, which is the key thing that we look for in fabric duct. So you have your lightweight, you can do anything with fabric that you can do with metal, any kind of fitting, Ys, Ts, offsets, cones, reductions, whatever. Then you have the option of picking any type of hole pattern you want. And of course, a lot of times that's left up to us at the manufacturers to decide the correct thing, but you can give us parameters. You want so much velocity, you want it to penetrate this far. You can even say this zone needs to be cooled and skip an area and go to another zone. Because the main thing that fabric duct uses for is transporting and distributing at the same time so that you mix the air thoroughly in the room. But that can be, again, very tailored to the situation and the application that you're using here. But when we do things correctly, the speed of the air coming out of that hole will pull the air that comes out of the surface part of the duct back into the airstream. So there's really no air loss in the porosity of the duct until you get up into the much higher porosities. So again, we were going to talk a little bit about the air distribution. If you look onto the left, you can see the nozzles. And those nozzles are just a small little extension of plastic. But that extension holds the airstream in place so much better for a long distance. Now that does add a little bit of cost to the product. It's about a 10 to 12% increase in price across the board for depending on how many nozzles. If you have a ton of nozzles, 4 or 5 rows, then it gets a little more expensive. But it can penetrate and push that air down precisely where you're looking for it to be. 50, 60 feet is not uncommon for us to do, especially when you get into the Vario nozzles and the larger nozzles. And there's different approaches from this in the industry. Different manufacturers approach this differently. Most do offer a nozzle of some type now. But where we stand out a little bit different is the Inject Flex. It's the hole size, because everything is done on a laser at KE Fabritech, and because we actually control the fabric production, it gives us the ability to cut this in ways that a lot of people can't. So we can go from hole sizes all the way from 1/4 of an inch up to 2 3/4 inches in hole size. Now that gives us a lot of flexibility, and the average penetration for this type is around 30 feet. When you get for the 2 3/4 to 2 inch to 1 3/8, as you move into the smaller holes, you get into more of a comfort situation where the velocities are reduced. And we look at a 10 to 12 foot throw capacity on those, and we don't advise much more to get it down into the occupied space. But these two are your main options, and that's what we see typically across the United States and here in most of our projects are the Inject Flex holes for the average application, and for the specialty applications where we're solving problems, we get into the Dire Jet. And I don't know if a lot of you are familiar with Fabric Duct, have used a lot of it, but we have grown a lot in the last decade. When Fabric Duct first came out, you pretty much got a round duct and it went flat when the system turned off. And then when it turned on, there was a huge problem of pop. Well, the Fabric Duct industry kind of said, okay, that's not acceptable. We got to fix that. So they looked at different mounting systems and suspension systems. That's where you come up with the 2-row, the 3-row, the internal and the external arches. And then we come up with 360-degree internal hold open rings. Now, those are very, very useful in certain situations, and we do see them used quite a bit. So when you take the 360-degree rings and you couple them with, say, a 3-point hanging system, you're really putting more metal in the duct than needs to be put in there. Because the 3-point and the 2-point, the duct doesn't deflate fully like it does with a single point where it falls down flat. If you look at these examples of the double hanging and the triple suspension, you'll see that only the top part will deflate during a double suspension, and on the triple suspension, you only get the two sides between 12 and 3 and 12 and 9 that actually deflate. So the systems, even if they start up really fast and really hard, those type of ducts won't pop. But the internal hold open system is used mainly in single point for aesthetics, to hold the duct open so that it looks full and it doesn't get that flat. The other thing that we've done in the Fabric Duct industry is we come up with horizontal tensioning so that we pull the duct tight horizontally. Pulling the duct tight horizontally gives it the appearance that it is completely filled with air at all times. And there's some good applications for this, especially in exposed places like you see behind me here in my background. When you're in a showroom situation, things of that nature, you want that duct to look full and inflated all the time. And those horizontal tensioning systems, they work perfect for those type of things. So the last thing we'll talk about is the governing codes for Fabric Duct. And this is just a little bit of information. Back in 2015, UL took all of the different smoke and fire codes and erosion and mold and mildew, and they rolled it into one test, which is UL 2518. And that was based off of an AC 167 testing standards. And those tests are smoke and spread, high temp, erosion, mold and mildew. So for a fabric duct system, and now they made us test systems, not just the fabric itself. The system had to be tested. That's with the rings, with the zippers, with the mounting hardware, everything went in to UL to be tested. And it had to pass all the tests. One of the big ones was a high temp because it's put in an oven and baked for 6 weeks at high temperature, internal and external. So once they did that and it got implemented, then NFPA 90A and of course International Building Codes, both of those picked up on that. And they lined out some rules. UL did, and everyone else, NFPA 90A picked that up as well, which it should be in entirely exposed locations, and it's under positive pressure, and it shall not pass through fire rated construction. You can put a sleeve in between rooms and you can join it. We do that all the time. But these are the big code issues. So when you look at fabric ducts, you want to look for UL 2518. That means the material and the system itself has passed through a very rigorous testing system to get there. So you don't have material eroding into the airstream, mold and mildew growth is minimalized. Usually about 65% humidity before any mold or mildew can form on the dust particles inside of the duct, because polyester usually can't hold that mold and mildew to it. It takes some dirt inside of there to take care of that. And lastly, the high temperature. If you're in a really tall room or putting it way up high in an auditorium and you're going to have a huge delta T difference, that high temperature test is important. And with that, I'm done, and I turn it back over to you with your prizes for the day.
Again, thank you very much. Excellent information. If anybody has a project that they're thinking about using Fabric Duct, we're more than happy to help design it with you guys. Just reach out to your long sales engineer. Thank you, guys.